Good afternoon. Today we're going to learn about the distance formula and line segments and also how the Pythagorean theorem relates to this. So first let's look at the distance formula. Last year you learned in algebra the distance formula, and that's just the distance between 2 points. And then last week we learned that when you indicate a distance of 2 points, you just write the first point and the second point, and this means right here the distance between the 2 points. That's just review. And review from last year, to find the distance between those 2 points, you take the difference of the first the x coordinates and you square them. And you also take the difference of the y coordinates and you square them. You add that value up and take the square root. So let's look at it as it applies to geometry. So first of all, write your coordinate grid. Do your y and your x axis, and then what I'd like you to do, I'm not looking at points right now, you just want to draw a triangle in that coordinate grid. And as you're going along with the video, you can pause it at any point so that you can catch up. Label your points A, B, and C, and then you're going to put, for points A, you're going to put x sub 1 comma y sub 1. That just means the first set of x values and the first set of y values. Go over to point C. Well, point C is at a different point on the x-axis than point A. So that's why you're going to put x sub 2, because it is a different x value. However, you'll put y sub 1 because it's the same y value. We're not going up or down in any direction. For point B, you have the same x value as C, but you have a different y value than all of them, so that's why you're going to put y sub 2 for the y value of B. We learned last lesson that the distance between just 2 points when you're just on a number line is the difference of those 2 points, and you take the absolute value of that. And the difference between these 2 points are the absolute value of the x values. So we learned those two things. When you're creating the distance formula, that's how they found that out. They know that from point A to point B, that distance is going to be that first distance between the 2 points squared plus the second distance between the 2 points over here squared. So let's do an example. So I'm going to put my triangle, and I'm going to start my first point at 1, 1. So I put a dot there. And my second point will be at 1, 3. So I'm going to go up 2 more and put, this is a tiny triangle. And my third point will be at 5, 1, so I'm going to count over 5. 1, 2, 3, 4, 5, and up 1. So then I'll connect my lines to make my triangle. And my point B is here, and my point C is here, and my point A is here. And I want to find the distance of the line segment BC. So for that, I just need my points for B and C. So let's first of all write all of our points. So point A, the coordinate is 5, 1. For point B, it's going to be 1, 1. And for point C, it's going to be 1, 3. So I want to find BC, so I'm just going to be dealing with the B and the C. So my formula above, I'm going to write it here. I'm going to do the square root of my 2 points. So I'm going to do x2 minus x1 squared plus y2 minus y1 squared. So using that formula, I'll put my square root. And I'm going to look at my points. So my x values for B and C, I'm going to do 1 minus 1, because those are my x values, 1 minus 1. And I always go in the same order. for my y values. So if I did 1 minus 1, I'll do 1 minus 3. And I'm going to square it. So 1 minus 1 is 0. 1 minus 3 is negative 2. But negative 2 squared is 4. So I'm going to get the square root of 4 here. And the square root of 4 is positive 2. And it also could be a negative 2, but remember when we're talking about distances, we will be using positive numbers. So I know it's 2 units. And let's double check it just by looking at it. So I'm doing BC. So I go BC. And I'm going to count from point B to point C. 1, 2. So I can check it when I'm looking at that. However, I'm going to be looking at AC now. And that one's a little more difficult because it's going halfway through points. So let's use our formula. And now we're just dealing with the A. Whoops, sorry. Let me get it again. So now we're just dealing with the A and the C. So you'll just be doing this point okay. You'll be doing just A. Something's going on with my pen right now. So let's see. You'll be doing A and C. Okay, so we do our square root. Our formula is above. So I'm going to do my first x values. So for A and C, I'm going to do 5 minus 1 plus, then I'll do my y values, 1 minus 3. So that's 4, and 4 squared is 16. So I have 16 plus, and negative, or 1 minus 3 is negative 2. Negative 2 squared is 4. So I'm going to get the square root of 20. And that will be coming out to approximately 4.5. And that's approximately. So the distance, if you look at it, you can kind of see the 4.5 in there. If two lines are the same distance, you call them congruent. And the way you can list that is by this. These two are not congruent. But let's say we did have some lines that were. So let's say CD is congruent with GH. That just means congruent. It means equal, same amount, congruent. You're going to be using that a lot. Okay, now let's look at the Pythagorean theorem and the distance formula. Now you're going to know how that Pythagorean theorem actually works. So we learned before that to find the distance on a number line from one point to the next, we take the absolute value of those integers. So we did x2 minus x1, and because this is going up and down, we're doing y2 minus y1. So for the distance formula, you'll recall that AB equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Well, to relate this to the Pythagorean theorem, let's try to get rid of this square root here. We don't want it right now. So remember, to undo a square root, we do the opposite of that, which is to square it. So we're going to square everything here. So if we square the distance of AB, we get AB squared. And if we square this side, that gets rid of the square root. So really, we just have x2 minus x1 squared plus y2 minus y1 squared. So relating that to the Pythagorean theorem, this is just the distance from A to C, right? And this one is the distance from B to C. And this over here is the distance from A to B. So let's rewrite that using the Pythagorean theorem. So if you look up at line AB, it is actually a little c, correct? and we're squaring that because it's squared here. This distance here is from A to C, which is the little a. And this distance here from B to C is the little b, so we square it. So that's how you get the distance formula to turn into the Pythagorean theorem, and it actually works. You're going to use this tomorrow, and you're going to apply it to an activity. See you then. Bye-bye.